Now our third proof of closure. Just continuing on, we're now in the middle of giving the formal description of the machine begin that recognizes a starred language. Okay. So the second point, the start state would just be Q0. Remember that was that one state we put outside N1 to allow for the possibility that your input string might just be the empty string. It was this sort of special case. Right? So we started in Q0. Now what are the set of accept states for big N? Well, there'll be the accept states for N1, that's F1, right? Plus this extra state, extra starting state that's outside N1 that has an eta arrow to the starting state of N1. Right? So it'll be F1's accept states plus this starting state Q0. Okay. Right. Now, as usual, again, the hardest part is specifying the transition function delta here. So 3 bars, by definition. Now, again, this one puzzles me. It's consistently the same problem. So I feel I'm missing something, but I'm missing it consistently in all 3 cases. So I'll probably keep missing it in the examples to be solved at the end of the chapter, and then I hope something will happen, and there'll be a click. Oh, that was it, and then I'll tell you what it is. So now, if I'm having trouble with it, maybe some of you are as well. So if you're puzzled and you're thinking about it and you find a solution, the solution, what is it that I'm missing? Please email me, so long as it's not too far in the future from what is it now, September 2012. Okay. All right. Okay. Now there's only one part. There's only one NFA we're using as a part in this bigger machine. This bigger NFA, big N, right? So the transition functions of the part, there's only one of them. So there won't be any delta 2s, it'll just be delta 1, right? Because there is only one part. Okay, so we're talking about the star. We're detecting a starred language. So the input string is just a whole bunch of concatenated strings where each string is a member of your language, A1. Okay. So if you're in the middle of detecting a string, okay, and you haven't yet got to your, the end of the string, you haven't yet reached your one of the accept states, well, just use your transition function for N1. So that's what this is, which makes sense, all right? This one I don't follow because it's how can this label not be eta given that's what's on the diagram? Am I being too literal? I mean, is it possible there might be other labels on the arrow that he hasn't written? This it's the same problem 3 times now. This I don't understand. Okay, now so the next. That might be a clue. Anyway, okay, so this one I don't understand. Now the next one. So what's happening here? You're in an accept state. So you found a string that belongs to the language. Okay. So then using the eta arrow, you branch back to the starting state of your N1, which is Q1. Okay. So your set of next states will be whatever this one, the usual. you'll include in the set of next states will be the starting state, because you've reached an accept state. In other words, you've detected, you've recognized, you've accepted a string, one of the strings of the language. And so the set of next states will be, your usual, like here, the usual, and the start state. So you have an extra copy made, and this machine will start in state Q1. All right. Now, what's going on here? So, what's happening here? Oh, now this was the special case. So this is the next state, right? So the current state's Q0. That was the start state, the state that's outside N1. And you put it there to solve this problem of you did not want unwanted side effects that would arise if you made your starting state of N1 also an accept state. If you do that, I haven't gone into details why, but if you do that, you get all these unwanted negative side effects. You get strings accepted that you don't want. Okay, so what's going on here? So your current state is Q0, and what's that? That's the start state of your N, the one that's outside N1. Okay, and what do you want to happen next? Well, you want it to move to the start state of N1. Okay, and what is the start state of N? Well, it's just Q1. Right? So that I understand, and you jump from that state to that state via an eta arrow. So that I understand. Okay. Now, what about this one? Yeah, this just copied verbatim out of the text. Okay. So what's going on here? So we're in the start state outside N1. We're in the start state of big N. Okay. And the arrow does not have an eta marked on it. Yeah. How could that be? Again, the same problem over and over. So there's something I'm missing. So it's looking as though it's possible to have non-etas on these arrows. I mean, that's what seems to be implied. Yes, do you agree? So maybe that's what I'm missing. Well, confused. Okay. Well, for the moment, I give up. Anyway, there's the formal specification of the transition function for your machine big M, and therefore you have constructed the machine. It behaves. Its behavior, its task is to accept concatenated strings, of any number of concatenations. That's the definition of star, and therefore it detects A1 star. Okay, that's its job. And therefore this language, the A1 star, has an NFA that recognizes it. And therefore, by definition, this A1 star is a regular language. And it's regular because there's an NFA that recognizes it. Okay, and A1 could have been any regular language from the set or the class of regular languages. And this language, whatever it was, A1, when it starred, is still recognized by an NFA. Therefore, this A1 language, when it starred, is a regular language. So that means that any language you take from the class of regular languages, when you star it, you get the result is still a regular language. Therefore, that set, that class of regular languages is closed under the regular operation called star. Okay, so that's the end of this whole section. Been quite a lively section. And now we get on to a whole new section. So it's the third section of this chapter. There are only 4 sections in the whole chapter. So major. We enter into a major new piece of theory, and they're called regular expressions. So you're familiar now with regular languages. They have NFAs that recognize them. Regular operations, regular operators like union, concatenation.